All right, so this is probably the most important thing that I'm going to show you here today, and I want you to pay really, really close attention to this. Super, super hyper important. The distribution of p-values under the null hypothesis is random. That sounds a little bit like word salad, right? But we just learned what all these terms mean, so let's kind of break it down a bit. Well, the null hypothesis, like we just said, is the assumption there's no difference between A and B, right? So if we're running a null test, it's just going to be our A variation versus another A variation. The distribution of p-values is just the spread. Remember, a p-value is an output of a statistical test. So what this is saying is that if we run AA tests over and over and over again, we are going to see a spread of p-values that looks like this chart here. Okay? Meaning if I decide to run an AA test, there's no difference at all. It's just as likely I could end up with a p-value as 0.8 as a p-value of 0.2. It's just as likely I could end up with a p-value of 0.6 as 0.4, or with a p-value of 0.95 and 0.05. Okay? So what this is telling us is that if we run 100 tests where there is no difference at all, we can expect 5 tests to have significant results where none exists. This is what we refer to as a type 1 error. Okay? It means that we see a significant value based on a threshold that we set that's not really there.